Hi everybody, this is Mrs. Lehman with Math with Mrs. Lehman. Happy Monday. Today we are going to be doing a lesson that involves fun things, but I won't give any spoilers right now. Let's go over the bell ringer. First of all, it says complete the proportion. So we have 4 to 5 equals what to 30? Who can help me out with that one? Liz.
4 to 5 equals 24 to 30.
Okay, how did you get that, Liz?
I got it because 5 times 6 is 30, so you have to do the same to the numerator. So you had to multiply it by 6, and that equals 20.
Beautifully said. Nice job. So I'm just going to draw that work out. So times 6. So times 6, and that is 24. Nice job. All right, this next one. You looked at this one, you said 8 to 12 equals 12 to what? And you probably went, 8? I can't multiply 8 by anything without getting really crazy to get 12. So, what did you need to do, William?
So what I did is that I found a common denominator for 8 and 12 and whatever number. So the common denominator for 8 and 12 an equivalent fraction for 8 and 12 could be 3 and 4. So what I did then is that I just went up a step ahead. So 12 eighteenths is also equivalent to 2 to 3. Said that wrong.
Yeah, you misspoke. That's fine.
Yeah,
all right, so you said that 4 goes into 8 and 4 goes into 12, right? And you
Yes.
simplified down from there. So you got 2 to 3. That's what
Yes.
you said. Okay, so hold on. So simplify this to 2 to 3. Okay, maybe some people did 4 to 6 too. Either way, it's fine. And then to get from 2 to 12, what did you do?
To 2 to 12, I multiplied by 6.
Very good. So 3 times 6 is
18.
18. Nice job. All right. Okay, so 2 times 6 is 12. 3 times 6 is 18. So our missing number was 18. Any questions on that? Who here had that right? Woo-woo. Okay, I'm going to pause this for a second. We are now moving on to the math joke of the day. It says, I see you have some graph paper. You must be plotting something. Ha 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 ha. Ha ha. Alright, you probably can't fully hear the class just groaning because they're sick of my jokes. Too bad. Alright, we're moving on. We went over this on Friday, our beautiful double number line. Then we started this, and I'm not 100% sure where this class left off. It looks like we have a lot to do with this. Am I correct?
Yeah.
Okay, so that's fine. All right, so it says that Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown, West Virginia for a tournament. The distance between Yonkers and Morgantown is 400 miles. And we're going to add a word here to the next sentence. It says the total trip there will take 8 hours. The train schedule is provided below. Alright, so if they go to Allentown, that's 100 miles, Carlisle 200, Berkeley Springs 300, Morgantown 400, and then they have their way back on the next ratio table. So we need to create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. So her rate of speed is not, or the train's rate of speed is not changing. It's going at a pretty consistent amount. All right, so let's go ahead and put this info in our chart. So the first amount of miles they have us going is 100 miles. So 200 was the next one, 300. You get there. Oh, no, you're not there yet, are you? Or was it? Yeah, 400 miles it said. Yep, so you got there. Now you're turning around. You're coming back. 500, 600. We could continue this ratio table on for a few to make it all the way home. Because who wants to get stuck in Allentown? Well, actually, no, that would be Carlisle, wouldn't it? So 400 500 would be Berkeley Springs, Carlisle. Can't have that. So we're going to go 700 and then 800. Okay. So the other piece of info that we had was that it took us 8 hours or for 8 hours to get there. So that was when you traveled 400 miles. So we need to fill in the missing pieces of this chart. All right, does anyone have any ideas on what that would look like? Jaden.
So, 4 times 2 equals 8, which is the 400 miles. So I think that 300 will take 6 hours.
Very good. Who agrees with Jaden that that would be 6 hours? Very good. Yeah, it would be. So well, let's go ahead. We're counting by 2s over here, right? So let's go to 4, and this would be 2. Then down here, 10, 12, 14, and 16. Does anyone know what we're multiplying by when it comes to the hours? What do we multiply the hours by to get to the miles?
We double the first number of the miles. Or
Nope. We're not doubling the hours to get the miles. We're multiplying it by what?
2. Multiplying it by 2.
No. We're not multiplying it by 2.
Multiplying it by 30?
Nope. 2 times 30 would give us 60. 2 times what gives us 100? William.
50.
Very good. We're multiplying by 50. Does everybody see that? So that means in 1 hour, how far would they travel? Very good, Tim. 50 miles. So let's go ahead and fill this in on our double number line. So it's pretty much the same info. It's just in a different format now. So we're going to create a double number line to show the time it will take Kelly and her team to travel from Yonkers to each town listed. Then extend the double number line to include the cumulative time it will take to reach each destination on the ride home. So they want her trip there and back. So let's do time and miles. So time and distance, it probably should have said, but our time, we're talking about hours, and our distance was in miles. So if they travel 0 amount of time, they're going how many miles? 0, right? So if they traveled for 2 hours, how far did they get?
Miles.
Very good, 100 miles. 4 hours. What would that be? Carly? 200 miles. Yep, if you guys could almost, like, not really shout, don't yell at me, but if you could talk really loud, I think the microphone will pick it up, okay? So, nice try, Ethan. Next one will be 8, 400, 10, oops, not 10, ooh. Would be 500, 12 would be 600, 14 would be 700, and then 16 hours into their trip, so on their way back home, they would have traveled all the way back. All right? Pretty easy, right? Just keep scaling it up. All right, using the information from the double number line, how many miles would be traveled in 1 hour? So what would be right here? If this were 1 hour, what would that be? Timothy, coming to you.
50.
50, very good. And what you can't see on the YouTube video is me almost falling on my head trying to run over to Timothy. So that would be quite fun to watch, I'm sure. All right, so how many miles have we traveled in 1 hour? So I'm going to write 50 mph. What does mph stand for, Ethan?
Miles per hour.
Very good, miles per hour. So that means out of 1 hour, they would travel 50 miles. How do we know? What do we do with our ratios?
You divided by 50.
All right, very good. We found that connection of 50, right? So we use that to simplify the ratios, or to, what's the other word we use? Scale them down, yeah. So how do you know? We scaled the ratio. What am I doing? The ratio 100 miles to 2 hours down. And that's what Jasmine was referring to. She noticed that if you cut 100 in 2, it's 50, right? So we scale the ratio 100 to 2 down to 50 to 1. And we could also say we simplified the ratio or the fraction. Okay, down here we have the lesson summary, and on your module workbook, it's on the next page at the bottom. So if everyone could please look at page 38 at the bottom. It says a ratio table equation or double number line diagram can be used to create ordered pairs. Does anyone remember what ordered pairs are from 5th grade? Mackenzie?
I was going to say that.
Okay. We'll come back to that, okay? Please hold 1 second. Okay, I'm back. It says that we are going to pretty much turn this table into ordered pairs. Does anyone remember what an ordered pair is from 5th grade? Liz?
Isn't it where one number goes in and then another number comes out as a different number?
That's kind of what's happening here, but a coordinate is an ordered pair, all right? So this is an ordered pair right here, okay? You guys remember X and Y and all that stuff? All right, so if we were to write these numbers in the ratio table as ordered pairs, it would be 0, 0. Does anyone know what we call the coordinate 0, 0? Jaden?
We call the coordinate 0, 0 the origin.
Very good. It's where the X and the Y axis meet. All right, so this one would be 1, 3. This one would be 2, 6. And this one would be 3, 9. You always put the X coordinate first. All right? So we are going to do that same thing with a ratio table involving some pies. All right, so I'm going to go to the next page on your module workbook. It's on page 38. Okay? So it says complete the table of values to find the following. Find the number of cups of sugar needed if for each pie Carrie makes, she has to use 3 cups of sugar. So 1 pie, 3 cups of sugar. So let's fill that in. 2 pies would be how much, everybody? 3 pies? 4 pies? 5 pies? 6 pies? Very good. All right, so we are going to turn these into ordered pairs. So who can give me the first ordered pair? Carly. 1 to 3, very good. Why don't you guys finish that up on your own? Make sure you put parentheses around the ordered pairs. We're also going to assign each of these ordered pairs a label. So we're going to call this A, B, C, D, E, and F, all caps. All right, now our next step is to come over here to our coordinate plane. they gave us quadrant 1, which we'll talk about later on in a different module, but this is just quadrant 1. And can anyone tell me what this horizontal axis that's at the bottom of this is called?
Your X.
Very good. It's your x-axis. All right, and you can tell me what the vertical axis is.
The y-axis.
Nice job, Willow. So we will label that right here. And I remember that this is a y-axis because you can really make that very vertical when you write it. Okay, so now the other thing we need to think about is our values for our coordinates. So if you look at just the x values here, it goes from 1 to 6, right? So you guys in 5th grade were used to counting each line as 1. If we do that, we're going to have all of our entire graph smushed into this little section right here. All right? So here's the magic of this. We can essentially use a different scale for that. So instead of counting each line as 1, maybe we go 2 jumps and call that 1, or 3 if we have enough room. So in this case, we have enough room. If we count 3 jumps over, we can count that as 1. And one thing I want to warn you about, because it's a very common 6th grade mistake, is kids are often labeling the spaces. So this is 0, that intersection, all right? If we go over, it's that line, which would be 1. 3 jumps over on that line would be 2. All right, so if you could go ahead and label that, and I'll come around to check to make sure you're on the right track. So everybody's paper looks fantastic. One thing I do want to say is that you need to maintain the same scale throughout. If you're going to count 3 jumps over as 1, you have to maintain that and keep it consistent. All right, you can't go 3 over, call that 1, then only go 1 more over and call that 2. All right, so when we plot a point that's 1 over, we're going to have to go over to here and then go up. Any questions on that? All right, let's look at our y values. Our y values go all the way up to 18. All right, if you go ahead and count this y-axis, how many jumps there are, is there going to be enough if we were to say use 2? Let's count. How many lines would we need for us to be able to count every other line? So essentially we'd be counting by a half. Each line would represent a half, right? So do we have enough? No, we don't, William. Why don't we, William?
Total number of spaces here is 25. So there are 25 blocks, and 18 times 2 is 36, and that's way over 25. So
Nailed it. All right, nice job. So we're going to have to just use a 1-to-1 scale, so each line represents 1. All right, this bottom line is 0. We don't have to label every single line. Maybe we want to go up 5 and label that 5, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4. Another 5, that would be 10, 15, and 20. And that top one would be 25. Again, just make sure you're consistent. Make sure you're counting that bottom intersection as 0. All right, and we're definitely talking about the lines, not the spaces. All right, these papers look pretty good. I'm going to pause this video for a sec just to double check. Okay, we should also label these. So this bottom x-axis represented which one? The pies or the sugar? The bottom is what? Pies, all right? So we're going to label this pies. Up the y-axis, this is sugar. And we're going to put in parentheses a C. That's telling anyone looking at our graph that we measured the sugar in cups. All right? And then as a title, we're going to say, instead of saying X versus Y, we're going to say pies versus sugar. So we have our scales set up, we have them labeled, we have each axis labeled, and we have given our graph a title. Now the last and one of the most important parts is to go ahead and plot these points. So I'm going to pause the video, we're going to plot the points, and we will go from there. So just to go over one of these, you would go over 1 up 3. Now you're not going to go over 1 here, you're going to go 1 like right here, okay, and up to 3. So your first point should be right at that intersection. Alright, I'm going to pause this, we're going to complete the graph. Alright, so most everybody is done. A few people are finishing up, but one thing that's important to know is that your line, if this is a ratio table and they're all equivalent ratios, meaning they have the same value, you should be able to form a nice straight line. If all of a sudden you have a point that's, say, over here, then you know that something's not right there. Either that value isn't an equivalent ratio or you plotted something incorrectly. Alright? Does anyone have any questions on this? I'm looking around, I'm seeing a few people who still have not labeled their x-axis with pies and their y-axis with sugar. So make sure you do that as well. You also need to have these points labeled. So instead of writing the coordinates out, I chose to assign each one a name, A, B, C, D, E, and F, and put those on my graph instead, which is okay as long as I indicate that somewhere that was my intention. Alright, we are going to quickly do our double number line. So, again, we're going to do pies and sugar. So 0 pies is how much sugar, everybody? 0. 1 pie is 3. Yep, so let's just finish this. This is a lot of pies. Alright, so that is on page 39. Your homework tonight is to do the rest of 39, and we're going to write our story together. Okay, so we need to come up with a story that would be represented by the ratio of 1 to 4. First period said that for every 1 dog Mrs. Lehman has, she has 4 cats, which isn't true, by the way, but it does paint a nice picture of me as a cat lady. So, second period said that for every 1 pizza purchased, you received 4 free breadsticks. Does anyone have a suggestion that we could use for this class?
For every 1 McDonald's they build, there's 4 Burger Kings.
Ooh, I like that. Okay, what else can we come up with? Jaden?
For every 1 white chocolate's purchased, there are 4 regular chocolates purchased.
Oh man, it's all about food.
For every 1 ice cream sundae, there's 4 ice cream sandwiches.
Lots of ice cream?
For every 1 donut, there are 4 sprinkles.
Lame. I feel robbed. There's only 4 sprinkles.
For every 1 phone call, you get 4 text messages.
Ooh. Which one do we want to use? Who wants Ethan's? McDonald's. Alright, sorry Ethan. Who wants Liz's with ice cream sandwiches Sundays? Chocolate, white chocolate, regular chocolate. Okay, a few votes there. Who wants Willow's? What was yours again? Donuts and sprinkles. I like that one. Alright, how about you? What did you say?
For every 1 phone call, 4 text messages.
Who wants to text? Wow, that's a popular one. Alright, we're going to go with Justin's. So, let's write that down here. For every 1 phone call, there are 4 text messages. So the numbers for all the classes will be the same, but the scenario obviously has varied a bit. So what we're going to do, does anyone need me to go back to that? 1 phone call, 4 text messages. Everyone good here? All right. On the next page, we're going to set this up a little bit. So this is going to be calls to texts. All right. And that ratio was 1 call, 4 texts. Your job is to finish that ratio table. You are then, yes, this is going to be your homework. Then you're going to write these as coordinates when you're all done, okay? You can label these on your paper. I don't have a lot of room up here. For example, A, B, C, D, E, and F. Over here, you would then make your graph, okay? So again, labeling your X and your Y axis. Every time you make a graph, you're going to have to add a title, label your axes. Hold on 1 second, guys. So your job is to finish this graph, finish the table, and then you guys don't have a double number line on there, right? So you are golden. Have a nice day. Thank you for listening. Don't forget to like and subscribe.